Hello everyone, my name is Jiyun Gwak and I am a PhD student at Chungnam National University in South Korea. Today I will present my research about effect-based monitoring of coastal environment, derivation of effect-based trigger values, and identification of major toxicants. Thank you for this opportunity. Coastal sediments are important environment compartments, because they act as both long-term sinks and secondary source of contaminants. As contaminants accumulate in sediment, they can be released back into the environment and potentially affect aquatic organisms. Therefore, evaluating sediment-associated biological effect is essential for effective environment management. Traditionally, environmental assessment have relied on target chemical analysis. However, this approach can only evaluate chemicals that are already known and selected for analysis. In contrast, effect-based monitoring evaluates the integrated biological effect or all chemicals present in environment samples, including unknown compounds and transformation products. As a result, it provides a more comprehensive assessment of environment contaminants. To interpret biocell results, reference value known as effect-based trigger value or EVT are needed. EVT provides thresholds that help distinguish between low consum and potential consuming level of biological activity. When the biocell-derived equivalent concentration exceeds the EVT value, additionally investigation may be required to identify potential ecological risk and the responsible contaminants. Therefore, EVT are essential tools for translating biocell response into environment management decisions. When the biological activity is detected, the next challenge is identifying the chemicals response for the activity. To address this issue, effect-direct analysis combined with non-target screening can be applied. This approach links biological activity with chemical identification and enables this discovery of previously unrecognized toxicants in environment samples. Non-target screening often generates thousands of candidate compounds. To prioritize biological relevant chemicals, machine learning and QSAR approach can be applied. These tools allow us to rapidly identify compounds with a high probability of biological activity and greatly improve the efficiency of toxicants identification. Based on this background, the overall object of my research is to evaluate AHL and ER-mediated activity in coastal sediment and biota, using effect-based trigger values and to identify major toxicants. To achieve this goal, I first derived AHL and ER EVT values. Next up, I applied this EVT to environment samples to evaluate biological activities. Finally, I integrated effect-direct analysis, non-target screening based on machine learning and QSAR approach to identify major bioactive contaminants. The first part of my research focused on deriving sediment-specific EVT for persistent and non-persistent AH-mediated activity. In addition, I evaluated the applicability of derived EVT using real coastal sediment samples. This work was recently published in Environmental Toxicology and Chemistry in 2026. We derived sediment-specific EVT for both persistent and non-persistent AH activities using sediment quality guideline and related potency values. To account for unidentified bioactive compounds, a mixture factor was applied. As a result, sediment-specific AHEVT were successfully established. The derived EVT were applied to sediment from Busan Harbor. Most samples exceed the EVT value, indicating potential AH-mediated biological effect. This result demonstrates the usefulness of AHR-EVT for environmental assessment. The second part of my research focused on deriving ER-EVT for freshwater and marine sediment and identifying major ER agonists. This study is currently in preparation for publication. Sediment-specific ER-EVT were successfully derived for both freshwater and marine environments. Application of ER-EVT showed evaluated ER-mediated activity at several industrial sites. These findings suggest the presence of unidentified estrogenic compounds in the sediment. To identify these compounds, I combined effect-directed analysis, non-target screening based on machine learning and QSAR approach. Machine learning and QSAR greatly reduce the number of candidate compounds. Among the candidates, the etobastriol and heptylpalpin were confirmed as ER agonists. These compounds substantially improve the explained ER-mediated activity. My future research will apply AHR-EVT to coastal sediment and marine organisms collected throughout Korea. This will allow nationwide assessment of biological effect in coastal environment. Using the derived EVT, I will evaluate biological activity in sediment and biota, compare their biological relevance, and identify major toxicants responsibility for evaluated activity. Ultimately, this work aims to establish comprehensive framework for effect-based monitoring in coastal ecosystems. In conclusion, sediment-specific EVT were successfully development of both AHR-ER-mediated activities. The derived EVT enabled the assessment of biological active in environment samples and help identify areas of potential ecological concern. In addition, the integration of EDA and non-target screening based on machine learning and QSAR allowed the identification of previously unknown bioactive contaminants. Ultimately, this research provides a scientific framework for early detection of emerging contaminants, support evidence-based environmental management, and contribute to the protection of coastal ecosystem and human health. Thank you for listening to my presentation.